The data from NASA's InSight mission suggests the urgent conclusion that a massive water reservoir lies dormant beneath the surface of Mars. In fact, the reservoir may be enormous enough to flood the entire planet. This is one of the most remarkable reports in current space science. The fact that Mars is also known as the Red Planet is not a coincidence. The planet's surface is covered in iron oxide dust, which gives it its distinctive color. This dusty calling card goes well with the dry and cold face that Mars presents to us today, but if we turn the wheel of time back a good 3 billion years, we realize that Mars was once much more rippling. It is now thought to be certain that the celestial body was once adorned with rivers, lakes, and even full-blown oceans. The cool water is hidden in the cracks and pores of the Martian crust, which is between 1 and 2 kilometers high. The end of the life-friendly Marsh era also raises a fundamental question. Where did all the red planet's waters actually disappear to? Based on data gathered thus far, it appears that the polar ice caps of Mars are not large enough to store all the water of the former oceans. Calculations have shown that the Martian oceans could have covered up to 75% of the planet's surface, but a few dramatic climate changes and the loss of the dense atmosphere later left little remnant of the once so liquid face. Mid-latitudes. Below the surface against this background, most researchers assume that the red planet has simply released most of its water reserves into space due to the lack of a magnetic field. It was easy for the solar wind to sweep parts of the planet's atmosphere and therefore its water out into space. So much for the theory, but the bottom line is that there is also another explanation which does not locate the Martian water anywhere in the universe but still on the planet, and to find out whether the water in the Martian oceans could have retreated into the depths of the rocky crust, the team led by Vashon Wright from the University of California in San Diego examined the data from Mars quakes collected by the seismometer on NASA's InSight lander from 2018 to 2022, given that the seismological data had already shown that there is hardly any water in the Martian crust down to a depth of 300 m at the InSight site. One might think that the venture was not particularly promising, but sometimes you literally have to look deeper. The focus of Wright and his colleagues was on the middle crust of the celestial body, which is hidden around 5 to 20 km below the surface, and although the average annual temperature on Mars ices 68 degrees C, these underground regions could be warm enough to allow the existence of permanently liquid water at the upper edge of the Martian middle crust. Furthermore, previous analyses had already shown that the crustal region of Desire could be peppered with many rock pores, and so as part of their study the scientists specifically evaluated the seismic data, which could reveal something about the nature of the middle crust. The mathematical model of rock physics that was used here is used on Earth, for example, to detect oil deposits. But on Mars, it should bring something to light that was considered absolutely impossible. Not so long ago, enough water. For a planet spanning ocean, ultimately the analysis of the seismological data provided two insights. On the one hand, confirmation that the Martian mid-crust is porous as assumed, and that the cavities make up around 177% of the rock, and secondly, that the fine fissures and pores are actually filled with liquid water. In this respect, Rye's group stated that the data collected can best be explained by a middle crust of fractured magmatic rock, saturated with liquid water. In other words, there could be a huge reservoir bar of liquid water 11 to 20 kilometers below the surface of Mars. However, this exciting news is currently still accompanied by a small but, because this only applies if the results are representative not only for the location of the Mars probe, but also for the rest of the planet. However, if this is the case, Mars could have stored a groundwater deposit in its rock pores that is large enough to form a planet-wide ocean. What's more, the amount of water would even be enough to flood the entire surface of Mars 1 to 2 kilometers high. Against this background, the invisible reservoir could also explain what happened to the water in the vanished Martian oceans. It was not lost through atmospheric outgassing, but instead seeped into the depths of the Martian crust, where it has been preserved to this day in the form of poor water. However, anyone who believes that Elon Musk can already provide the drinking bottles for the future inhabitants of Mars is mistaken. In fact, the water reservoir would be inaccessible to future Mars visitors and stations, as there is simply no drilling technology that can penetrate to such extreme depths. But what can reach such extreme depths is life the home of Martians in spring 2021. Antarctic researchers were astonished what began as drilling through the so-called Filchner-Ronne ice shelf ultimately led to the completely surprising discovery of sedentary creatures that somehow managed to survive 900 m below the surface, far from any sunlight and without any apparent source of food. And then there is the mysterious world of life that has unfolded in the basement of the Earth in the form of the so-called deep biosphere, while this is mainly made up of bacteria, viruses, and fungi. These tiny survivors have already been detected in the sediments of the oceans in volcanic rock, and even in the solid bedrock of the continents. In view of this, you might think that the famous Jurassic Park quote that life always finds a way in the end actually corresponds to reality, well, at least on Earth. But what about the case of the hidden Martian water? Could life actually thrive in the extreme underground world of the red planet? Well, the researchers' short but profound answer is why not in this regard. Co-author Michael Manga from the University of California at Berkeley is quoted as follows: since water is a prerequisite for life as we know it, I don't see why the subsurface reservoir of Mars wouldn't also be a life-friendly environment. We have not yet discovered any evidence of life on Mars, but we now have at least one place that would, in principle, support life. But let's assume that Mars really does harbor, or once harbored microbial life. Why then have we still not managed to uncover the signatures of the tiny Martians? Well, the truth is that we may have already done so. Are these the traces of Martian microbes? Perseverance has been exploring the landscape and rocks in the Jezero crater on Mars for 3 1/2 years. Now landed on the red planet on February 18, 2021. The primary mission of NASA's rover is to gather soil samples for eventual return to Earth, but Persistence is also keeping its technical eyes open for potential signs of past Martian habitation. In fact, NASA declared a few weeks ago that the rover had made an unprecedented discovery. The iron oxide mineral hematite is present in large quantities on Mars, but this does not apply to the few irregularly shaped patches in the deposits that are millimeters in size and have a dirty white color surrounded by rings of black material containing iron and phosphate. In this regard, Persistence has located a unique rock formation at the northern foothills of the ancient Netivi Vallis River Valley, which has been named Chava Falls. It is decorated with broad white sulfate veins between them, which is a darker reddish substance. The rock, which measures about 1 meter in length and 60 centimeters in width, is the first concrete indication of organic matter on Mars. The idea that the colored spots might represent chemical reactions that microorganisms employ as a source of energy is very intriguing. Energy spectrometer studies have confirmed that organic carbon molecules are present in both the spots and their surroundings. In summary, the stain pattern combined with the iron and phosphates is comparable to the traces that microbes usually leave on Earth. In particular, these deposits are frequently linked to the fossil traces of subsurface microbes, which release iron and phosphate when they break down iron oxide. What do all of these points really mean? Has Persistence finally produced conclusive evidence of the existence of extraterrestrial life? Though not necessarily. There is also unmistakable evidence that water once fell over Chava Falls created a life-friendly environment for Martian bacteria. NASA stresses that while organic molecules on Earth can frequently be linked to bacteria, they can also form through geochemical pathways that do not involve living things. For instance, during volcanic activity, we still do not know how Chava Falls formed or whether lava may have played a role. Nevertheless, experts have used all of their remote sensing tools, according to their own statements, and have photographed the rock day and night from every possible angle. To truly understand what is behind the boulder, it must be brought to Earth, where a thorough analysis using highly precise instruments could finally reveal whether the Martian rock is indeed adorned with ancient traces of life. At this point, you can add new click marks to the subscription button. Go ahead and give it a thumbs up. Additionally, subscribe to ensure you never miss another thrilling video from us. We hope to see you soon.